Utah, and they all are in a plane. They are in what physicists call a very equilibrated system. Any violent collisions in the system died out long ago, and because of that they are paper thin. They trace out the plane of gravitational equilibrium around the planet. And despite their enormity, if you took them to put them all back together again to make a moon of the proper density, they would be no bigger than this little moon here in Enceladus, which can be seen here in this picture that I predict is going to put the space artists out of business. Bear in mind in these pictures, because it's confusing, I think, for those who haven't seen it, these are not bands in the atmosphere. These are the shadows cast by the rings onto the northern hemisphere of the planet. So the processes ongoing in this disk of material, as I said, are believed to have occurred in the disk of dust and gas from which the planets form, and reaching even 1 trillion times larger in size in the disks, these pinwheels of dust, of gas and matter that form the spiral galaxies. In fact, the mathematics and the physics underlying the structure in a spiral galaxy was co-opted with very little change and applied to the study of Saturn's rings to predict the presence of waves in the rings that in fact were found by Voyager when Voyager visited in the 1980s. So there is a great deal to be learned in studying Saturn's rings about the very early stages of our solar system and also about processes that are going on in disk systems throughout the cosmos. So in this sense, what we hope to learn from Cassini is truly universal. The rings exhibit a bewildering variety of structures, most of it unexplained. The features that we do think we understand quite well are those that are produced by orbiting moons. I'll say a lot about that later. But this is a view that we had of Cassini's ring, Saturn's rings as Cassini approached before we got into orbit. And I'm just going to orient you here. This is the A ring. This is the Cassini division discovered by Cassini. This is the B ring. It's the densest portion of Saturn's rings. And then this is the C ring. And they look different. The structures in them are different, and we don't know what that means just yet. Perhaps these are different ring elements that had different origins. But these are the kind of questions that we will be hoping to answer as the years unfold. Now, Saturn is very, very far away. And Cassini was very massive. As I said, it was 6 metric tons at launch. And even launching Cassini on the largest launch vehicle that we had at the time in the American arsenal, and that was a Titan IV missile, along with solid rocket motors strapped onto it, and then putting Cassini on top of a Centaur upper stage wasn't enough to get it directly to Saturn. So we looped it around the inner solar system twice. It encountered Venus twice. It encountered the Earth. And then it encountered Jupiter for the final push on to Saturn. These were all gravity assist maneuvers where the spacecraft steals momentum from the